The topic of my presentation is MS Interpreter for Accurate Mass Data, Correlating Structure to Mass to Charge. It includes both a video and a handout, and there will be some additional things discussed in the handout not discussed in the video, so you should check it out. Only basics of using MS Interpreter will be discussed in the video and the handout. For more detailed information on MS Interpreter, see my website. Also, there's a lot of help in using MS Interpreter that you'll find on this slide, so refer back to it when you want to find out additional information. You can send any result in the chromatogram search results list to MS Interpreter. So we'll go to the software, right-click on the entry of interest, send to MS Interpreter. And what it's going to send is your unknown spectrum, which is the top part of the head to tail at the top, the red, and it's going to pair it to the structure for the library. So it's going to pair those two and say send to MS Interpreter. Anything in black, it should tell you something about, so we'll click on the ion here. That's the precursor ion, and you can see it's very good error. It's very low, so that's a good result. And you can also click on all the fragment ions if you want to and see how their error associates with the observed versus the theoretical. Again, that's very good. You can also send other things to MS Interpreter from this display in the chromatogram. If you right-click not on the structure, but it's not there, but over on the spectrum, but over in the text, you can say send to MS Interpreter. In this case, it's going to send the MS2, the MS-MS spectrum of the library to MS Interpreter with the structure in the library. So that's if you just want to learn how things fragment. So we'll do that. Again, same results. But here, this is not your unknown spectrum. It's the spectrum from the library. If you click on the top here, again, nothing there, but right-click here, and you can send your unknown spectrum to MS Interpreter. Here, you'll have to go get a structure and put it in here if you want to compare it, because it just sends the data over for the raw unknown spectrum with no correlation to a structure. And also, when it comes over here, you need to make sure when you're using this window to go to Options. The other two came over as automatically being protonated in the options, but that's not the case here. So if you want to use this and compare it to a structure that you'll paste in here, I'll show you how to paste a structure in later in another part of the program and say OK. Now when you bring it in, it'll work properly. If not, if it's ionized, that's in the EI mode and the fragmentation model will not fit your MS-MS data. You can add your own spectrum in MS Interpreter. First, you need to get a structure from the results list or the drawing program of your choice. So let's go back to the software. In this case, I'll send the atropine to the library search, to the lib search window to get what I want. So at the top here is our unknown sent over from chromatogram, and the search results are displayed below. You can see again, it tells you it's atropine, but if we wanted to send these and pair them together, what you have to do is right-click on here. You need to get a structure in your clipboard. So you copy the structure to the clipboard. Now you go up to the top and select it, right-click on it, and say Send to MS Interpreter. Now when you get over here, click in the structure box, and you can either use a Control-V or the paste command to put it in there. So now our structure shows up here, but you'll notice things are in white now. The problem is here, you need to go to Options because the default is ionized. That's the EI mode. You need to do MS-MS, so you need it to be in the protonated mode. You say OK. Now we get the proper result that we expected. So it's somewhat the same as when we sent it over from the chromatogram window. It's just another way. If you have anything that you want to pair together when it's in the lib search window, you need to do it in this manner. My last example will be adding your own structure from a drawing program and pairing with an unknown spectrum. This will be an example with the hybrid search result in the lib search window. We'll talk much more about hybrid searches at a later time in the series. So let's go to the software again. I did the lib search in the MSMS hybrid mode, as you can see at the bottom. The best hit was this material at the bottom, and it says it's 132 difference, which is 3 times 44. So if you know that that equals 3 ethylene oxide groups, this compound has more ethylene oxide groups than there are unknown, but it's the same class of compounds. So it's a very helpful in identifying the unknown. So you could just draw this structure by hand in the drawing program, but it's a lot easier if you start with something and modify it. So I'm going to right click on this and say send to default structure editor. And now it's opened here. So what we need to do is get rid of 3 ethylene oxide groups. We're at 582 here. So we get rid of this, 2, 3. And now we have the structure that we want, something that weighs 450. You can see at the bottom here. So you need to select this, especially if you'd had more than one structure in here. You need to select what you want to send because there could be multiple structures in this drawing program that you've been working on. So you say edit, copy, and that'll put it in the clipboard for you. So you can take it back to the NIST search program. So you go back to the NIST search program. Now we have what we want, and we'll right click on this and say send to MS Interpreter. Again, it'll come up in the white mode because in general you need to make sure it's in the protonated, not in the EI mode. So I'll go ahead and fix that. Now I need to put my structure, so I left click in the structure box, say edit, I can paste it or hit a Control V, and it comes in. And you can see for the ion out here, we have our parent ion and it's off by 1.2 parts per million. And then you can just click at the other ones to see the parts of the structure you want. There's a part with the tail on it with some glycol losses, and it all makes sense. It's a very logical spectrum for this class of compounds. So it's probably a very reasonable identity for the unknown. So I hope you found this useful in using MS Interpreter to correlate your observed ions in your unknown to that of a structure proposed by yourself or the data system. Good day.